The Internet of Things is the network of physical objects, devices, vehicles, buildings and other items which are embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. The Internet of Things allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for more direct integration between the physical world and computer-based systems, and resulting in improved efficiency, accuracy and economic benefit when IoT is augmented with sensors and actuators. The technology becomes an instance of the more general class of cyber-physical systems, which also encompasses technologies such as smart grids, smart homes, intelligent transportation and smart cities. Each thing is uniquely identifiable through its embedded computing system but is able to interoperate within the existing Internet infrastructure. Experts estimate that the IoT will consist of almost 50 billion objects by 2020. British entrepreneur Kevin Ashton first coined the term in 1999 while working at AutoID Labs' Connected Objects. Typically, IoT is expected to offer advanced connectivity of devices, systems, and services that goes beyond machine-to-machine communications and covers a variety of protocols, domains, and applications. The interconnection of these embedded devices is expected to usher in automation in nearly all fields, while also enabling advanced applications like a smart grid, and expanding to the areas such as smart cities. Things, in the IoT sense, can refer to a wide variety of devices such as heart monitoring implants, biochip transponders on farm animals, electric fans in coastal waters, automobiles with built-in sensors, DNA analysis devices for environmental, food, pathogen monitoring or field operation devices that assist firefighters in search and rescue operations. These devices collect useful data with the help of various existing technologies and then autonomously flow the data between other devices. Current market examples include smart thermostat systems and washer-dryers that use Wi-Fi for remote monitoring. Besides the plethora of new application areas for Internet-connected automation to expand into, IoT is also expected to generate large amounts of data from diverse locations that is aggregated very quickly, thereby increasing the need to better index, store and process such data. Early history. As of 2013, update, the vision of the Internet of Things has evolved due to a convergence of multiple technologies, ranging from wireless communication to the Internet and from embedded systems to micro-electromechanical systems. This means that the traditional fields of embedded systems, wireless sensor networks, control systems, automation, and others all contribute to enabling the Internet of Things. The concept of a network of smart devices was discussed as early as 1982, with a modified Coke machine at Carnegie Mellon University becoming the first Internet-connected appliance, able to report its inventory and whether newly loaded drinks were cold. Mark Weiss's seminal 1991 paper on ubiquitous computing, the computer of the 21st century, as well as academic venues such as Ubicomp and PACOM produced the contemporary vision of IoT. In 1994, Reza Raji described the concept in IEEE spectrum as moving small packets of data to a large set of nodes, so as to integrate and automate everything from home appliances to entire factories. Between 1993 and 1996, several companies proposed solutions like Microsoft's At Work or Novell's Nest. However, only in 1999 did the field start gathering momentum. Bill Joy envisioned device-to-device communication as part of his 6 Webs framework, presented at the World Economic Forum at Davos in 1999. The concept of the Internet of Things first became popular in 1999, through the AutoID Center at MIT and related market analysis publications. Radio frequency identification was seen by Kevin Ashton as a prerequisite for the Internet of Things at that point. If all objects and people in daily life were equipped with identifiers, computers could manage and inventory them. Besides using RFID, the tagging of things may be achieved through such technologies as near-field communication, barcodes, QR codes and digital watermarking. In its original interpretation, one of the first consequences of implementing the Internet of Things by equipping all objects in the world with minuscule identifying devices or machine-readable identifiers would be to transform daily life. For instance, instant and ceaseless inventory control would become ubiquitous. A person's ability to interact with objects could be altered remotely based on immediate or present needs, in accordance with existing end-user agreements. For example, such technology could grant motion picture publishers much more control over end-user private devices by remotely enforcing copyright restrictions and digital restrictions management. So the ability of a customer who bought a Blu-ray disc to watch the movie becomes dependent on so-called copyright holders' decision, similar to Circuit City's failed DIVX. The following is a list of countries by IoT devices online per 100 inhabitants as published by the OECD in 2015.